Recording. All right, so we're recording. All right, here we go. Hi, everyone. Welcome to Wintellect's Introduction to IoT on Azure webinar. My name is Josh Lane, and let me tell you a little bit about me before we get started, just so you have some idea of who's talking at you for the next several minutes. I am a principal architect at Wintellect. I do a variety of things for Wintellect, primarily consulting, but I also do some training, a little bit like what this webinar is, and I also do some content development for a number of clients. So that's things like writing white papers and doing POC work on new technologies, that kind of thing. I have almost 20 years of experience as an architect and developer, principally on the Microsoft stack. First doing C++, a lot of C++ work earlier in my career. More recently, a lot of .NET work. I've actually started to do some work with Node.js, and certainly over the last few years, a lot of work in the cloud. Mostly Azure, but some in AWS as well. I am a Microsoft Azure MVP. I'm very proud of that. And I live in Atlanta, Georgia, in the United States, and I run and organize a meetup called Azure in the ATL. It's one of the larger Azure meetups, at least in the United States. If you have any questions, I'll do my best to answer some questions at the end of the webinar if we have some time. If I don't get to them and you have any, you want to reach out to me with any additional follow-up, please feel free to do so at my email address there. You can also get me on Twitter at JPLANE. A little bit about Wintellect as well, my employer. We are a small boutique software consulting and training company. We work with a number of clients. We've been in business for well over a decade, and we work with a number of clients in the United States, but also around the world. Primarily, we are our responsibilities or the things we do are software architecture and development consulting, whether that's kind of building or running software projects front to back for clients, doing architectural engagements and assessments, that sort of thing. We also do and offer a number of instructor-led training courses, both virtual and in person, on a number of technologies, a lot of Microsoft stack technologies, as well as modern web development, mobile development, that sort of thing. Okay, so let's dive into IoT. Before we talk about IoT on Azure, I thought it would be useful to spend a moment talking a little bit more generically about what a robust IoT platform, some of the attributes that a robust IoT platform should have. So in no particular order, obviously one of the most important things that an IoT platform needs to do is to scale. Specifically, scalability in IoT tends to center around two main things. Certainly the number of devices that you're going to have connected to your IoT platform, whether it's 1 or 10,000 or 1 million or even several million. So that's one aspect. And the other aspect, of course, is the amount of data that those devices will be sending to your IoT solution, but also the IoT solution sending back to the devices, so data ingress and egress. Another aspect that's important for any IoT platform is the ability to manage all of those devices. So again, whether you have one device or whether you have 1 million devices, the ability to uniquely manage, identify, and manage those devices is particularly important. And this comes up with things like the ability to revoke or disable a device, perhaps if a particular device is malfunctioning or it is compromised by a hacker, then the ability to uniquely identify that particular device and disable it so that it no longer communicates with your platform is particularly important. Communication, I mentioned this sort of in passing a moment ago, but communication, it's important that communication from an IoT platform is bi-directional. and not only is it bidirectional, meaning communication can go from device, of course, to the cloud or device to the platform, but also in the other direction. So commands can be issued from software running as part of your solution, your IoT solution, back to the devices to tell them to reset themselves, update firmware, etc. And not only is that bidirectionality important, but an additional aspect of that, which is also important, is the notion of this notion of it being occasionally connected or intermittently connected. Devices out in the field, whether by design or by happenstance, certainly will not always maintain a dedicated connection to your IoT platform or to the cloud, and so the ability to sort of batch communications back and forth in both directions is particularly important. And of course, the notion of a secure connection is also sort of goes without saying. That's something that's absolutely necessary. Another aspect is the ability to support many communication protocols, whether those are open standard protocols or proprietary protocols, perhaps that are specific used for specific devices. That's very important. Another aspect, which is sometimes overlooked, is the notion of support for a variety of data formats. So not only establishing the actual communication path, but the nature of the data that's being passed back and forth. In many cases, devices don't support any notion of a standard format, and the data that they pass back and forth for telemetry, for instance, is customized and specific to the device. And so the notion of being able to parse those formats and be able to handle those in kind of a customized way is very important for any IoT platform. And another aspect of handling data in an IoT platform is the notion of where that data is and the different scenarios that exist for querying and processing that data. So the obvious one is, of course, things like data at rest. So for instance, telemetry data comes in from devices, the IoT solution accepts that data and ultimately stores it in durable storage, and then later queries, some query facility exists for querying across that data to do analytics or to integrate with an application, that sort of thing. And that's kind of a standard typical thing. The more interesting scenarios are things like streaming and the ability to query across streamed data, so that in other domains, this is sometimes referred to as things like complex event processing. And so this is a very important aspect of any IoT platform, certainly any modern IoT platform, the ability to query and interact with data in sort of this event-driven fashion, and maybe be able to detect anomalies in a device state so that you can interact with and sort of handle those events in a just-in-time fashion. So those are kind of the high-level attributes, but let's go one level deeper. I'd still like to stay kind of technology agnostic for a moment, and let's talk about a little bit more specifically about what a reference IoT architecture would look like. I've actually borrowed this diagram from a document that Microsoft curates, which is titled very similar to this. It is a reference IoT architecture document. It's a very useful document. I would actually recommend that you take a look at it if you haven't, and if you're not familiar with it. I have a link for it at the end of these slides. These slides will be made available, by the way, to everybody on the webinar after we're done. So you can take a look at that link on your own time and follow that to actually track down this document. But this diagram is really interesting because, again, it doesn't presuppose any specific technology, but it gives you kind of a visual depiction of kind of the major moving parts of an IoT architecture. So the first one, there's kind of three main areas you can kind of subdivide here, and so I've kind of broken it down this way. The first major responsibility for any IoT architecture, of course, is the ability to sort of connect and interact with, identify, and track the state of devices. And so you can see kind of the red box there kind of outlines the major responsibilities that constitute the device connectivity and management functionality. So these are things like managing the public endpoints that devices talk to, doing any sort of protocol negotiation that might be necessary, doing device provisioning or deprovisioning. So the ability to sort of say, oh, this is a new device, this device has ID X, and so now I know what it is, and I can sort of keep track of it so that I can communicate with it, I can revoke its provision if I need to, that sort of thing. Of course, things like authentication are very important here, as well, on authentication on a device by device basis, as well as tracking device level state, and potentially representing that state, keeping a copy of it in sync in the cloud, so that I can do queries across that data without actually having to reach out to every single device. If I've got 2 million devices in the field that are connected to my IoT solution, it's a bit difficult for me to reach out in a just-in-time fashion and do device queries to 2 million devices. So if I have the ability to sort of have a mirror image of the state of that device and kind of keep that relatively in sync in the cloud, then device queries suddenly become much easier to do. A second aspect of this reference architecture is this notion of data processing and analytics. What are we going to do with all this data? How are we actually going to process it and make sense of it? And so we talked previously about that notion of durable storage and doing queries against data that have been written to durable storage, and that's certainly important. But then there's also this notion of stream-based processing and event-based processing, and so that's where some of this comes in as well. What also you can see from the diagram, what also ties in here ultimately is this notion of analytics, and even this is where things like machine learning plug into an IoT solution. So if you're doing something, for example, like predictive maintenance, then the ability to plug in machine learning algorithms against either data at rest or even data that's being streamed is very key and very important. And so that's kind of this meaty middle tier of this diagram is kind of where that fits in. And so then finally we have this notion of other kind of, whether they're third-party applications or services or your own custom applications that live on top of or beside this IoT solution, this IoT data. Ultimately, no IoT kind of solution lives on an island, right? We're not just collecting all this data just so that we can write it to durable storage and be done with it. Typically, we're going to present it in sort of a dashboard functionality or with reports. We're going to export it to partners who may be interested in that data. We're going to do something with it. And so there's this notion of integration, which I call presentation and business connectivity. This is just the notion of third-party integration or integration with external services and applications that may be out there in the wild, whether they're things you control or not. And again, that's just something to be aware of as you're building out generically, as you're thinking about an IoT solution and an IoT architecture and putting it together. Just something to kind of keep in mind. Okay, so let's switch gears. And we'll talk, instead of talking kind of in generic terms, we'll talk more specifically about the things that Azure itself, Microsoft, provides for IoT. When you start looking at some of the IoT guidance that on the Azure portal, for instance, you will inevitably run into a description of something called the Azure IoT Suite. The Azure IoT Suite is, the name's a bit confusing because if you're familiar with other Azure offerings, a lot of the documentation and references that you'll find on the Azure website refer to specific technologies or specific product offerings that are billed by the hour or by the minute. And so if you're familiar at all with Azure and you start to see references to Azure IoT Suite, it can become a little bit confusing because you start to think the initial reaction is often, well, the Azure IoT Suite must be this formal feature or formal product offering. And it turns out that the Azure IoT Suite is really, for the most part, a marketing terminology, which isn't to denigrate marketing or denigrate the notion of the Azure IoT Suite, but I just want to clear up some confusion. As the slide notes, the IoT Suite is not a single technology or service. It's really a set of umbrella technologies. There are several technologies within the Azure sphere, the Azure ecosystem, which I'll talk about on the next slide, that kind of constitute several of which would constitute a particular or be used in a particular IoT Suite IoT solution on Azure. The one interesting thing that the IoT Suite does offer, from by way of an offering, I suppose, is the notion of this notion of prescriptive guidance. So, as Microsoft has noted that a number of their key customers who want to do IoT on Azure, a lot of their problem space falls into two main areas, and the first two that they offer by way of prescriptive guidance are a remote monitoring solution, kind of a template solution, as well as one around predictive maintenance. And so certainly that doesn't constitute the full extent of anything you could do in IoT on Azure, but these are two sort of reference guides that they actually provide code for you that you can deploy just with a couple of button clicks into your Azure subscription. And you can see this code, you can get this code up and running, and they serve as very good reference points or jumping off points for you to take that code, take those solutions, and customize them and use them for your specific needs. So if you need to do something like a remote monitoring solution, I'll show a demo, in fact, in a few minutes of a remote monitoring solution where you may have dozens or hundreds or even millions of devices in the field, and you need to kind of keep track of accept telemetry input from those devices, keep track of their state, fire off events if you notice anomalies in any of the state. That's a typical remote monitoring solution. And so you can use this prescriptive guidance from Microsoft as a means to build some of that if you don't want to build all of it from scratch yourself. Similarly, the predictive maintenance solution or scenario guidance allows you to build a similar kind of scenario for predictive maintenance of devices. So being able to track their lifetime, recognize when a device is typically going to fail, and when you may need to maintain it or fix it in some way before it fails. And this particular scenario guidance is very interesting because it incorporates Azure machine learning. So if you happen to be interested in knowing how to or seeing how to incorporate machine learning into an IoT scenario, then that would be a particularly good bit of code, or that'd be a particularly good place to look. If you note the URL on the screen, Azure IoT Suite.com, you'll find a bunch of information on that site, including that's actually the site you can use to deploy those solutions into your own Azure subscription. So, talking a little bit more about some of these technologies in the Azure ecosystem that kind of fall under this umbrella of IoT Suite. This is by no means an exhaustive list, but gives you a bit of a representative sample of technologies that you will often find, at least some of these in a typical Azure IoT solution. Whether it's device-specific technologies on the edge, or technologies that manage or deal with data at rest, or incoming data or streaming data. Technologies like Azure ML or Power BI for either doing analytics processing or displaying and observing the results of that analytics processing, as well as custom logic that you may want to incorporate into an IoT solution. So things like Azure Functions or Service Fabric actors. If you happen to be familiar with Service Fabric actors and the Service Fabric technology offering, actors make a very good tend to be a very useful part of an IoT solution, certain IoT solutions, for sort of doing mirroring state and behavior of devices in the cloud and in the field. That's a particularly interesting technology. But in the interest of time, since this is only an hour webinar, I certainly don't have the time to dive into detail in all of these technologies. As you know, that would be a week-long course probably. But I am going to take a closer look at one of these technologies in particular, which is really the core of the IoT Suite and the IoT technology platform, which is on Azure, and that's the Azure IoT Hub. Now, the Azure IoT Hub acts as the slide notes, acts as the secure cloud-based IoT gateway, that remote gateway that devices will connect to and interact with on that public endpoint that's provided by the Azure IoT Hub. It is ultimately that conduit between your custom business logic, your analytics, your machine learning algorithms, any custom applications that you have on the back end. Think of that diagram that we were looking at a few minutes ago, that reference architecture. It is that gateway, that conduit between those things and the devices that you have talking, that you're actually managing out in the field. It has a responsibility, again, if you think about kind of abstractly those responsibilities that we talked about for a robust IoT solution. The IoT Hub, specifically in Azure, has that notion, or is responsible for that notion of provisioning, managing devices, and establishing and maintaining communication, even intermittent communication, but reliable communication with potentially millions of devices out in the field. It does this on a per device basis, of course, so it maintains a discrete identity for each device that it manages, and is able to authenticate and authorize behaviors for devices, and even revoke the authentication, or the ability for devices to interact with the IoT solution. It has the ability to do that on a per device basis. It establishes bidirectional communication. And so there are various patterns that exist for kind of pushing data back and forth. I'll talk some more about those after I do a quick demo. But some of those patterns are things like telemetry data, of course, essentially the state of a particular device or set of devices, that state being pushed from the devices up into the cloud, up into through the Azure IoT Hub, and then written to durable storage, or processed using event processing, stream processing in some way. So that pattern is certainly the device to cloud communication pattern is fully supported in IoT Hub, as well as some of the behaviors that go from cloud to device. So things like provisioning and unprovisioning devices, new device instances, updating firmware, and this would be things like issuing commands to the devices for the devices to reach out to a well-known location to update their firmware, cause the devices to reboot remotely, or issue custom commands. So, for instance, if you had, say, 1 million thermostats out in the field that you were tracking and managing through IoT Hub, you would have the ability through custom code, say from a web portal integration, you click on a particular device or set of devices, and then issue a command for those thermostats to raise their temperature, ambient temperature, by 5 degrees, say. And that would be issued as a custom command from the IoT Hub to the devices, or the set of devices that you care about. And those devices would in turn interpret that command in a device-specific manner and perform whatever operation corresponds or maps to that command. Those sorts of interactions are fully supported in Azure IoT Hub. As far as specific communications protocols, IoT Hub supports 4 main protocols, standards out of the box, as well as custom protocols. If you need for whatever reason your devices support a custom protocol and you can't use any of the existing built-in ones, then you have the ability to add your own and support your own if you need to. You'll obviously have to do a little bit of work on one or both ends of the communication channel to essentially use your custom protocol and then convert that back and forth as necessary to something that either end will understand. If your device supports the custom protocol, but the cloud, the IoT Hub doesn't support it, then you would need to have what's known as a cloud gateway or a custom cloud gateway. You would need to build that and then translate from your custom protocol into one of these 4 existing protocols that IoT Hub supports, and then forward those messages onto the IoT Hub. It's a fairly standard plug-in mechanism or extensibility mechanism that is certainly supported in the IoT Hub. The other thing to note about IoT Hub is that it does support durable storage of messages. and is able to maintain kind of that intermittent, occasionally connected device connectivity. It uses something called the inbox pattern, which is not specific to IoT Hub certainly. It's the notion is basically like it's like an email inbox where if a device is not currently connected to the IoT Hub, then messages that are intended to go from that device to the cloud are batched and then sent when the connection is reestablished. And similarly, messages that are intended for the device are batched on the cloud side, and then when the connectivity is reestablished, the messages are pushed down to the device. Fairly standard pattern. So if we go back to that reference diagram that we had a moment ago for that reference IoT architecture, you can see that this block in particular is where the Azure IoT Hub fits into that diagram. So it really encompasses three main capabilities. It is that public cloud gateway that provides that public endpoint that the devices talk to. It also provides the box on the left-hand side, the gateway box. It provides there's an SDK. It's what's called the Azure IoT Hub Gateway SDK, which allows you to build a custom gateway that might do things like the custom protocol negotiation, or if you needed to do specific authorization on the edge as opposed to authorization in the cloud. Maybe you want to do analytics on the edge, so you want to do data aggregation and do some sort of processing, analytics processing out in the field, as opposed to doing it all in the cloud. You have the ability to build a custom gateway using the Gateway SDK to do that sort of processing. And the other main thing that the IoT Hub provides in this diagram is, of course, all of the device management, device identity tracking, provisioning and deprovisioning, state management, that sort of thing. Okay, so I've been talking for a few minutes, so let's transition a little bit, and I'll show you some code. What I've done is I've created a small demo that basically simulates transit buses moving around the city of Atlanta. In this case, I'm actually using real-time data from the transit buses in the transit system in the city of Atlanta. So this is geolocation information, latitude and longitude, and a little bit of extra metadata that determines whether the bus on its particular route is early or behind schedule or on time. This is actually freely publicly available information from the city. So I'm using that data, and I've created a simple simulator application which will take that data and then periodically every 30 seconds or so will publish that data to an IoT hub that I've already established in the cloud, as though each of the buses were pushing that data itself directly. Of course, that's not happening. The buses themselves they're pushing that data to the city's data center, and then the data center actually makes that data available separately. So there's a little bit of an extra hop in there. So I'm simulating the bus communication. It's not quite direct. It's a little bit indirect. Nevertheless, it does get the point across. So we have this. This is a little bit of a remote monitoring kind of application where we can see the location of the buses. We have 3 listeners off of our event hub. If you look at the diagram on screen. In fact, I can have a slightly bigger version of this, so let me pull that up. Let's see. Here we are. So if you look at this diagram, so we have our simulated buses, which are pushing data into our IoT hub. Our IoT hub essentially has 3 separate, what are called consumer groups. These are basically 3 separate copies of all of the messages that are pushed into the IoT hub. One exists purely for historical reasons. So every message, every bit of telemetry that we get from the buses, we're going to store in blob storage in Azure. The idea being that we don't really know in the future how we might want to use this data, so we're just going to collect all of the raw data and put it in blob storage, and then at some point in the future we'll have data scientists, they'll come along and they'll decide that there's some interesting things they want to do with that data, and they'll have a copy of it there that they can do whatever they want to with it. That's a fairly typical, again, a fairly typical pattern in an IoT solution. So we've copied that here. The next listener that we have is informational data, and this data is written to a document DB database. Document DB is the hosted, managed NoSQL database that exists in Azure, and we're using that specifically to keep track of the most recent state of each of the buses. The idea being that we're going to need that state to do some additional processing and for some additional informational display in our web app that I'll show you in a moment. The last listener is what I call the location listener. And again, this is just receiving the same copy of the data that the other two listeners are receiving. In this case, I have some custom code which is taking that location information, and it's getting rid of most of the extraneous metadata that comes with each event, and is merely taking the latitude and longitude and the ID of the bus, and is pushing that data to a web app. In particular, the web app pushes that data out to all connected browsers, all browsers that are connected to my web application at that particular time. And the web app, the browsers are displaying a Google map with updated positional information for each of the buses. And so as new events come in and the position of the buses changes, then we update the Google map in real time. And so I'm using SignalR push technology to basically push that data from the web app to each of the connected browsers. So that, hopefully you get a sense from that picture of kind of the flow of data in this, relatively simple IoT solution in Azure. Okay, so let me show you real quick. I'll show you some code, and I'll show you some of the details in the Azure portal in just a second. But let me just run this code real quick and just show you, I'll give you a quick example of what it looks like. So if I'm in Visual Studio, I'm just going to hit F5, which is going to start up my simulator and my listener. And so my simulator and my listener are just console applications that are getting data from the transit system and now pushing the data into the browser. And you can see each of these points represents a bus actually in the transit system. So if I click on one of these, by clicking on each of these markers, I can get some additional information in a pop-up. This tells me the trip ID, the vehicle ID, the route number, and then whether the bus is actually on time or not. And that extra information that appears in this window is coming from my document DB store, which maintains the current state of each of these buses, each of these devices. So if we keep looking at this, we'll actually see the positions will start to change over time. Of course, that takes a few minutes, so we won't continue doing that. But you kind of get the sense of certainly that there are a lot of buses in the city of Atlanta, and that you can get a sense of the information that you can track through an IoT solution like this. Okay, so let me close these down since we don't need to look at those anymore. Okay, and before we look at code, let me open up the Azure portal and give you a sense of what this looks like in Azure. So if we go back to just as a refresher for the diagram real quick, we've got an IoT hub, and we'll have an IoT hub in Azure. We're using blob storage in Azure. We're using document DB, and we also have a web app. The web app is actually running locally on my machine, but you could certainly publish it into Azure and run it there as well. For simplicity's sake, I'm just running it locally. So let's look at a couple of these moving parts in Azure. The first thing we'll look at is the IoT hub. And so I'll open that up. And again, just as a refresher, the IoT hub is that cloud gateway that allows us to push data from devices into the cloud, and as well would allow us to issue commands from the cloud back down to those devices. Since this is a simulation and a slightly contrived example, I don't have any good examples of pushing data from the cloud down to the devices. I'm purely doing one-way communication in my demo, but certainly IoT Hub allows you to do two-way communication if you need it. In the portal, there are various kind of interesting bits in here. I can show you real quickly the set of devices that I have connected. you can see I've actually got 15 or so pages of devices. So I won't page through them all. It's not terribly interesting, but you can see each of them has a device ID. This device ID corresponds to the vehicle ID that comes from the metadata that I'm actually getting from the transit service. So this is actually a real identifier that comes from the raw data that I get from that transit service feed. And I'm just using that as my unique identifier for my device in the cloud. The other interesting bit that I can show you in here is the messaging properties. If I scroll down a bit, you can the relevant, interesting bit here are these consumer groups. So you can see that I've created a consumer group for history, info, and location, which again, if you go back to my diagram, you can see the corresponding elements in the diagram. Again, consumer groups in IoT Hub correspond more or less, you can think of them as copies of the data that is pushed through the IoT Hub. So the idea is that I would like to maintain and have available a copy for each of the listeners that are going to be doing something with this data. And that's a useful pattern to avoid things like the competing consumers problem. So if you have ever had to build messaging applications where you maybe have many listeners on a single pipe listening for events, one of the problems you have to solve is, well, what happens when I have multiple listeners who are trying to compete for the same set of events? IoT Hub gets around that problem by using this notion of consumer groups, or at least it helps get around that problem by exposing this notion of consumer groups. So here's where I have those three. I can create more if I need to. By default, you get one called default, but you can create multiple of them, which I've done. So that's my IoT Hub. Let's now take a look at the document DB database. When I open this up, document DB is, again, that's the managed NoSQL store in Azure. I certainly could have used a different store. I could use something like a SQL Server, a managed SQL Server database, or something else. I chose document DB because it happens to map very well as a document style database. It stores JSON data, and that happens to map very well to my needs for this particular IoT solution. I just want to store a single JSON document that corresponds to the current state of each of the devices, each of the buses that I'm tracking in my IoT solution. So when I open up my document DB store in Azure, in the Azure portal, what I see here is my document DB account. I can actually have multiple accounts. I just have one in this case. And so I can have multiple databases per account. So I have one database that I've called default. So I'm going to click on that. In document DB, databases themselves have things called collections. Collections are just what they sound like. Those are collections of documents, JSON documents. And so I have a single collection called buses, which I will click on. And you can see some statistics in here as far as how many requests I've made against this collection, etc. So I could, the thing I'm interested in is looking at the Document Explorer, which will allow me to actually see the state. I have a little bit of latency here. I can open up, I can pick one of these documents, so ID 1665. If I click on that, I can see the state of this particular vehicle. So every time this particular bus sends a new message to the IoT Hub, then the document DB listener will receive this and update. It does an upsert. So if there is no record for 1665 in document DB, then the record will be added to the collection. If there is one, then the record will be overwritten with the most recent record. So you can see in this case, I've got latitude and longitude information. I've got things like the vehicle ID and some other things that are mostly just metadata information. The details of this aren't super important, but just know that this is kind of what this looks like. It's one good way for tracking the state of the world for an IoT device. Okay, so let me close this out. And the last thing, well, the next thing we'll look at is our storage account. And if you'll recall, I'm using the storage account, I'm using blob storage in particular, to store the device history or essentially the history of all of the messages that I receive for every device. So this is just a standard Azure storage account. It allows you to store blobs, files, tables, and queues. I'm storing blobs. I'm not storing anything else. In fact, what I'm going to do is I'm going to switch and use something called the Azure Storage Explorer. It turns out from the Azure portal, you can't actually look at the contents of blobs. So that's not actually super interesting if I look at that here. So I'm going to switch and use a tool called the Azure Storage Explorer. This is a free download. If you Google Azure Storage Explorer, you'll find this tool. What this allows me to do is it allows me to look at my storage accounts. This is my storage account, and I want to look at blob containers, and in particular, I want to look at the history blob container. And so the way I've set this up is that it sort of has a folder hierarchy based upon the date that this data is archived. So I'm in year 2016, I'm in month 10, I'm on day 13, and you can see that I have a single JSON document in here which contains all of the telemetry data, all of that information that I've received today from the buses, from the devices that I'm tracking. So I'm going to open this up, which will download. Take just a second. It'll open it up for me in Visual Studio Code, since that's what I'm using for JSON. And you can see, again, the details here aren't super important, but you can see the history of all of the messages that I've received, all of the data I've received while my IoT solution is running. And so again, if you track this over time, storage in Azure is extremely cheap. If you track this over time, you don't even have to do anything with it right away, but eventually you may have a data scientist or somebody who wants to perform analytics on this data to figure out exactly how late are buses on a particular route, or maybe correlate routes and buses with driver performance, that sort of thing. The means to do that, in order to perform that type of processing, maybe in a machine learning scenario or in some other analytics scenario, the ability to do that hinges on your ability to have lots of that data available. And so that's what we're using blob storage for here. And again, that's a fairly typical pattern that you'll find over and over again in things like an IoT solution. All right, so I've talked about where the data is ending up and how these listeners work, but the one thing I've sort of skipped a little bit is what is the conduit? That something is actually listening on the IoT hub and then writing the data to DocumentDB. And just like something is listening on the IoT hub and writing data to blob storage. And what is that something? What's actually happening there? So what I'm using to do that is in Azure is something called Stream Analytics. And Stream Analytics is more or less what it sounds like. It's a processing solution for listening to data streams, defining inputs and outputs, and streaming the data, taking that data from the inputs, doing any transformation or querying or processing on that data that I need to do, and then writing that data to an output. And so it lets you define multiple inputs, multiple outputs. In this case, this is the Stream Analytics job for my writing my state data to DocumentDB. So if I click on IoT Hub in here, you can see the details of this aren't super important, but this is where I've configured this job to listen to my IoT Hub. So I've got, this is the name of my IoT Hub, Wintellect-webinar, configure some security information, authentication information. It's listening on the info consumer group. So if you remember my diagram previously, I have different consumer groups for each of these listeners. This one's using the info consumer group. So that's the input coming into the job. And then my DocumentDB, I can get rid of this. If I click on DocumentDB as my output, you can see similar configuration for DocumentDB. So I'm telling the job, use the Wintellect-webinar DocumentDB account, use the default database, the buses collection, and then a little bit of information as far as like what should it use for the actual the ID of the document itself. I want to use the vehicle ID property in JSON. So it's going to use that and recognize that. DocumentDB will recognize that as the unique identifier for that document. So in between the inputs and outputs for an analytics job, for a Stream Analytics job, I can define a query. This is a bit difficult to see, so I apologize. But if you can see this, as I'm highlighting it, Stream Analytics allows you to use a SQL-style syntax for defining transformations or filtering, that sort of thing, on the data that's coming into the job for pushing it to the output of the job. And so I happen to just be taking all the data as is and pushing it from the input to the output. But if I wanted to, I could do additional filtering or aggregation. I could do windows like time slices, so I could essentially batch or buffer messages for, say, 5-second windows or 30-second windows, and then aggregate that data in some way and then push it to my output. These are the sorts of things that Stream Analytics allows you to do. So I have that's the job that pushes data from my IoT hub to DocumentDB. I have a similar job that pushes data from my IoT hub to my blob storage. It's very similar, so I won't go into the details of that. Okay, real quickly, to show you a little bit of the code, my solution, by the way, I should mention, again, just like the slides, I have all of this code, including detailed instructions on how to set all of this up in your own Azure subscription. I have all of that in a GitHub repository that will also make available via link at the end of the talk, so that you'll have the ability. You can go in and look at the slides. You can go into my GitHub repo, pull down all this code that you see here, and again follow it's a fairly detailed step-by-step set of instructions for setting all this up in your own Azure subscription if you want it. So bear in mind you can do that as well when the webinar is over. This solution has, my Visual Studio solution has 4 main projects. I've done this in C#. I have a web project which encapsulates all the details of certainly displaying the Google map on a simple HTML page. And again, I won't go into the detail of that. Couple of interesting things to note is that I am using SignalR. So if, let's see. Yeah, so here's where I'm pulling in the SignalR libraries. And if you're familiar with SignalR at all, the notion of connections and hubs in SignalR, this is where I'm establishing all of that. If you're not familiar with SignalR, just note that SignalR is a technology that Microsoft creates and supports, which allows you to push data from a server back into a browser. So kind of asynchronous. Normally browsers, of course, connect and request data and pull data from a server. This technology allows the server to actually push updates and changes back to the browser, any connected browser. And so this is how I flow changes from the IoT hub through the custom listener code that I have, and flow changes in position, latitude and longitude for each of the buses, back to the Google map. Again, you can explore this on your own time. If you have any questions or you're curious about how it works, certainly feel free to reach out to me via email. So that's the web project. I have a simulator project in here, which is the project that's responsible for reading the data feed from MARTA, is the transit solution, or the transit authority here in the city of Atlanta. And this is the URL where they publish all of their up-to-date bus information, latitude and longitude, that sort of thing. And so this particular project is responsible, this simulator is responsible for waking up every 30 seconds, reading that data feed, and then pushing that data into the IoT hub. So that's what's acting as the simulator. Similarly, I have a listener project or a listener solution, which is listening on the IoT hub, listening for data coming in particular, it's listening on, again, this location consumer group, and listening for that data, and then taking that data from the IoT hub, and then pushing it into the web project using just using Web API. So it's basically doing a post with the data from the IoT hub, and then the web project in turn, this simple Web API controller takes the data in the body of the post, and uses SignalR to actually push the data from the web project, from the web server, back into each of the connected browsers. So that's actually how that flow works. And then I also have a common project in here, which is just defines some common data types. Okay, so that's basically the demo that I wanted to show in the code. Again, you have the ability to go in and take a look at that code yourself. If you have any questions about it, again, feel free to reach out. Okay, so let's talk a little bit more in a little bit more detail about what the different patterns are and styles that exist for communication from device to cloud. What that looks like. You certainly have the ability, I talked previously about IoT hubs support for standard protocols like HTTP, MQTT, AMQP, etc. So to the extent that your device natively supports any of those protocols, you have the ability to not use any SDK or any additional software and have the device talk directly to IoT hub. And if you want to do that, you can. That gives you nice low-level control over everything that's going across the wire. The disadvantage of that, of course, is that you have to do all the work yourself. So if you prefer not to do all that work and you have the ability to, or the devices that you're working with have the ability to run what's called the device SDK from the IoT Hub device SDK from Microsoft, then you can use the SDK to give you a nice kind of higher level of abstraction for programming against the IoT Hub and communicating with the IoT Hub. So the device SDK actually works across a number of operating systems and devices. It works with a number of languages and platforms. So basically anything that can use Node.js, Java, Python. There's a C version of the library, so of course C works very well on a number of devices. And certainly there's a .NET version as well of the SDK. There's actually a good page. I think I have a link to it at the end of the slide deck. But there's a really good page that outlines, Microsoft keeps it up to date with all of the devices that are certified to use the device SDK and all of the different features that you can use from the different versions of the SDK. And so you can follow that link to kind of keep up to date on that. Another option you have for device to cloud connectivity with Azure IoT Hub is that you can use file uploads. So some devices interact with the cloud using just by pushing, say, CSV or XML or JSON, using FTP or something like that, some sort of file push or file upload. And so IoT Hub does support that as well. Something to note, IoT Hub does support, if you're familiar with or you've written code that uses the Azure Event Hubs SDK and APIs, Azure IoT Hubs are API compatible with Azure Event Hubs. So in many cases, the code that you may be using to communicate with Event Hubs will more or less work as is or very close to as is with IoT Hubs. So that's actually a really nice benefit from a migration standpoint if you've built prior solutions using Event Hubs. And I mentioned the Gateway SDK previously, and that's just something to keep in mind if you do have some interesting kind of custom scenarios that fall into some of these categories that you may want to accommodate in your IoT solution. Then IoT Hubs does have this notion of a Gateway SDK that allows you to build kind of custom logic and behavior at the edge, as opposed to doing some of that logic in the cloud, or in addition to doing some of that logic in the cloud, I should say. So keep that in mind as well. From the standpoint of cloud to device communication, I mentioned some of this previously, but just to kind of recap, all of these scenarios are supported by IoT Hubs. A lot of them are based on what's called the lightweight machine-to-machine or LWM-to-M protocol. I have a link to the spec for this protocol at the end of the slide deck, and this is an open standard created by a standards body. A number of manufacturing companies and software companies in the field belong to this consortium, and so this IoT Hubs supports this open standard, this open protocol. From the standpoint of the cloud of IoT Hubs talking to devices and issuing commands and the kinds of things it can do, things like rebooting, issuing remote reboot requests, factory reset of devices, firmware updates, initiating firmware updates of devices. These things are all fully supported. Certainly the notion of command and control style patterns like custom commands, whether those are things you want to happen immediately, or maybe you want to be scheduled in the future. Those are all supported by Azure IoT Hubs. And there's a couple of interesting scenarios around what's known as in IoT Hubs as a device twin. A device twin, it's a sort of a fancy way of saying it's a synchronized copy of the current reported state of a device where that state is maintained, that copy is maintained in the cloud. I mentioned this in passing at the beginning of the talk, but one of the things that's really difficult to do when you have devices in the field is to say you have 2 million devices in the field, is if you want to issue a query across all of them to kind of do aggregated information or aggregated queries. It's really difficult, and if not impossible, of course, to do that with devices in the field. And so the notion of having a device twin where you have, with some sort of tolerable latency, you have synchronized state of devices stored for you in the cloud, that enables you to do query across that state across those device twins without having to reach out to each of the devices every time you want to issue those queries. And so this is interesting for things like if you want to cause a configuration change or issue some custom command on a device, which is, again, like the thermostat example. You're going to change the temperature, increase it 10 degrees on a set of thermostats. And the thermostats will report their progress along the way. You basically tell the command, you issue the command to each of the thermostats and say, I want you to increase your temperature by 10 degrees, and that may take 1 minute, it may take 10 minutes, but the devices will synchronize their state and report their state along the way as they progress from 0 to 10 degrees warmer, and also potentially report any sort of error condition if they're unable to attain that state for some reason. So those are the kinds of scenarios, again, that are fully supported in Azure IoT Hub and are typical of all IoT solutions. Just a quick slide on pricing. Pricing is basically done on what's called a kind of a per unit basis in IoT Hubs, and a unit basically corresponds to allows you to kind of take the number of devices that you anticipate needing to support, and multiplied by the number of messages or data that those devices will be sending on a per daily basis. You kind of do some quick back of the napkin math, and then figure out kind of where in this spectrum you may need to fall as far as which of these sizes you might need for your IoT Hub. The one I'm particularly using for my demo is just the free one, which only allows about 8,000, as it says, about 8,000 messages per unit per day. And it only supports 1 unit of operation, so basically 8,000 messages a day, which, as it turns out, isn't very high. It's actually not that hard to hit that limit, even when you're doing a simple demo like what I was doing. Those prices, of course, are subject to change, so if you are particularly interested, you can see all that information on the Azure portal. And that's certainly the best source of information for that. As far as references go, I've mentioned that I included some in the slide deck. These are things like that reference architecture document. I would highly advise you, if you haven't seen that document, again, even if you're only sort of casually interested in Azure and maybe doing work with AWS, etc., that document is a really good kind of technology agnostic document. It does reference particular technologies in Azure, but it in general gives you a good kind of framework for a mental model for thinking about what a reference IoT solution will look like. There's really good documentation on the Azure portal on IoT. There's a book in here that I've referenced from Amazon, which is a good, it's a slightly dated book, but it still has some good information on patterns that you might see and might use with IoT in Azure and in the cloud. And just some other information on there as well that you can look at on your own time. Okay, so I think that is all that I have. I certainly appreciate everybody's time. We are just about out of time. I don't think we'll have much time for questions. But again, if you do have questions, anything in particular on the talk that you'd like me to talk about, then let me know, and I'll be happy to answer those offline on email. Thanks, everyone. Have a great day.